Hello friends, and welcome to a help tutorial for question number 4 on the Atwood Machine Lab. So this question deals with the derivation of the acceleration formula. Alrighty, let's first frame this question. Why am I asking you to think about a derivation? Pretend that you're an engineer working on the schematics for the elevators in the Eiffel Tower. It's your job to calculate the acceleration that each elevator in the tower feels to make sure it's safe for people. So, can you figure out an equation to calculate this acceleration of the elevators given their masses? You want to derive an equation that works for any elevator being used. Maybe different masses, maybe same masses, but you want to develop an equation that works for all types of the Atwood situations. So this is where deriving the acceleration comes in. But what even is a derivation? I recognize that y'all have not had a lot of experience with deriving equations in, like, for example, math class or science class. And I think this is a really, really important concept that we should at least touch on. So I'm not asking you to derive this equation as some form of physics torture. It's actually really important that we at least understand why derivations are important. So what is a derivation? In science, a derivation is when you look at the real world around us and use math to describe something about the system. So this is really where translating the real world into math, really physics, comes into play. So in this example, the Eiffel Tower is our system. It is what we are studying. And we want to figure out an equation that can calculate the acceleration of the elevator cars. More specifically, this equation should work every time. So it doesn't matter if our Atwood machine is the Eiffel Tower elevators. The Atwood machine could just be a simple system of blocks on a pulley. Regardless, this equation for an Atwood system should work every time. Again, this should work for all Atwood machines. And that's pretty darn useful, right? Instead of having to go test every single system, experimentally by hand, we can have an equation that can tell us what the acceleration would be. All right, so how do we do a derivation? The correct phrase we use for that is actually how do we derive the equation? Derive is also a verb. So step 1, we observe our system. Maybe we are this happy stick person watching the Eiffel Tower. Then we tie our observations back to math and equations that we already know. And then, in a nutshell, we smoosh those equations together until we can solve for the variable that we want. So we're connecting ideas about the world around us using math. And I hope that doesn't scare y'all, because I know you can do this. I know you can think about this and get through these steps. And that's really powerful. All right, so what are we doing specifically for this situation? Step 1, we are saying, these elevators in the Atwood machine are like free body diagrams. It's all about the forces. And then we say step 2. Well, we know Newton's second law, the net force is equal to mass times acceleration. So what we can do is apply step 2 to our masses, to our elevator cars, right? And then we end up doing math so that we can substitute equations and solve for acceleration. Both cars, both masses, experience the same acceleration. And that's a really important thing. That's how we can tie these equations together. So hold up, don't panic. Don't panic, don't panic. Y'all, I am not asking you to derive this all by yourself. I give you the full derivation in the lab itself. I'm not asking you on our first round of deriving equations to do it all from scratch by yourself. No. What I want you to do is write down the whole derivation I gave you, preferably on notebook paper. Don't just copy and paste it, so that you get practice with it. So that you get practice with, oh, okay, we do this step 1, step 2, now we substitute stuff in. I want y'all to actually see how we can use equations and basically flip-flop them into each other and solve for something else. So, in the lab itself, on page 2, y'all right here, I say, how do we quantify this acceleration? Let's derive it. Hint, 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 let's derive it. Y'all, steps 1 through 6, that is the derivation. I am asking you to rewrite, preferably by hand, so you get some experience writing it out, all of these steps, all of these equations. So again, we use Newton's second law and turn the elevator system, turn the Atwood system into an equation. Then we do some substitutions based on what we know. Then we do some more substitutions and rearrange. Then we do some more substitutions. I think y'all are getting it by now. This is a lot of substituting. And at the end of the day, we get to solve for acceleration. And if you notice, this acceleration right here is only dependent on gravity and the masses. So we can go from our starting material, right, the elevators or the whatever masses you're using, and use those values to calculate the acceleration. There we go. So don't panic. Y'all, I just want you to rewrite that derivation and get practice. Let me know if you have questions.